here for example 3, we're going to throw some data into our graphing calculator, and then we're going to compare different models and their r-squared values so we can see which one would fit our data the best. So if you plug in your speed into the your L1, and then your kinetic energy would be L2, when you plug those into your calculator, you should get something that's looking nice and pretty like these values. And then if you want to graph this, remember you need to go to your y equals. I'm going to go ahead and clear these out. But you need to turn on your plot 1. So make sure that's turned on. And then you can hit zoom 9. And when you hit zoom 9, you have a nice little, some points going like this. And it's kind of hard to tell, okay, does that follow a quadratic model? Would a linear model be best? Or would it be an exponential model? So we're going to try to find all of these models, and except for the linear. I guess we're going to find the power model instead. So if we're going to find the quadratic, we also need to list the r-squared values. So we're going to put all these r-squareds along here. And so in order to find a quadratic model, you're going to have to go to your stat button, go to the right to your calc menu, hit 5 for quadreg, and let's find our model here. So we're going to get a 0, 2, 3, 2, 6 for our values, and then we're going to have, or for our A, our B is going to be a negative 0.0127, and your C value is a 0.0082. So if we plug these in, or if we write these down here, 0.0233. So we're going to say y equals 0.0233, and that's going to be x squared minus 0.0127x plus 0.0082. And if we write down our r-squared value, that is a 0.9986. Not too shabby. So 0.9986. Well, it's going to be difficult to get any better than that, but we better not quit there. So let's keep moving on. So let's try to find an exponential model. So for an exponential model, we're going to go to our calc menu again. So stat, go over to calc, and we need to find your exp reg. Exponential. It's natural law. exp reg. So we're going to hit enter. L1, L2. Dun, 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 dun. There's that. So this one follows the form of y equals a times b to the power of x. So only the b is to the power of x. Your a is a 0.0052. Your b is a 3.7299. Here a 9er in there. And your r-squared's value is a 0.9917, so not quite as good as our quadratic. Well, let's go ahead and write these down. So we're going to have y equals a 0.0052. That's your a, and then the b is a 3.7299, all to the power of x. And we said the r-squared value is going to be a 0.9917. So still a pretty good model, but the quadratic is still a little bit better. So last one, let's try the power model. Let's go to your stat button and the calc. And if you can't figure out how to find your calc menu at this point of the year, go ahead, talk to your counselor, and we'll talk to your reading, and we'll talk to your English teacher and try to get you a reading coach, because that's pretty easy to find. So here on a power. Now this is different than your exponential model, because a power regression has the form of a times x to the power of b. Before, your exponential model was b to the power of x. So a power regression is going to end up with your a as a 0.0191, b as a 1.9966. Whew! Stopped at 2 sixes. And your r-squared is a 0.9979. So let's see how these compare here. So we're going to have y equals 0.0191, and then you're going to have x to the power of 1.9966. And your R squared value ends up being a 0.9990. So they're all pretty good models, but if you look at these, your quadratic model is going to end up being a better fit. So if you were to predict a value in the future, then you'd want to use your quadratic model over your exponential and your power functions. Granted, you'd be pretty close with your exponential and power functions, but overall your quadratic model would be a much better fit, and you would be able to predict in the future. Like I am predicting now that this example is over.